The domain package represents two things: the most general pieces of information, such as data classes, constants, and enums, which the program must virtually represent. Also, the most general things this program must do, which the program represents using functions and interfaces. In essence, it is the foundation of any new program I write, and I use a repeatable process to design my domain package or module. For a clear and simple introduction to that process, check out this video on my channel, How to Design Information Systems and Applications. That video is a recording of a talk I gave to some software engineers in Egypt about that particular topic. Anyways, most of the code in this package is simple, but it does include a design pattern, which I will introduce now. This package contains several interfaces, which are used to employ the repository design pattern. This pattern is also known as the facade pattern, and the general goal of the pattern is simpler than its technical definition. The technical definition of the facade or repository pattern is to hide the details of a subsystem, in this case data storage mechanisms, behind an abstraction, in this case an interface. Let's look at a practical example to make sense out of that definition. Our presentation logic classes will hold references to these repository interfaces instead of the classes which implement the interfaces. This gives several benefits to our presentation logic classes. They can be built independently of each other without causing a compiler error. They can be tested with a fake implementation of the interface without requiring us to change any code within the presentation logic class. Also, if we decide to use a different implementation of the interface, such as switching from file storage to a room database, we can also do that without requiring any changes to the presentation logic class. These benefits are a result of building software systems which are loosely coupled, and the repository or facade pattern is an easy way to promote loose coupling. In fact, interfaces in general tend to promote loose coupling. Now, don't feel the need to use this pattern everywhere. A good general rule is to use them in significant architectural boundaries. In this case, I am using them as a boundary between the front end and the back end of this application. To start things off, right-click on the domain package, go to New Kotlin file, and create a file called difficulty, and that's going to be an Enum class. Enum classes in Kotlin and Java and various other languages are useful for creating a restricted set of values. As we'll see later on, you can use sealed classes in Kotlin to create a restricted set of types. In any case, the main benefit outside of just creating that set of restricted values is that enums can greatly improve the legibility of your program, as we'll see in a moment. Let's add in our enum entries. Quite obviously, this enum will represent the difficulty of a given Sudoku puzzle. However, we need to add one more thing before moving on. We will actually be using some values for each of these entries in the algorithms to basically dictate the difficulty of the Sudoku puzzle. So in order to add a value to an enum in Kotlin, we need to give it a property or some properties. As you can see, our entries are now red, so obviously we need to give them some doubles. And that's everything we need to do here. Right-click on the main package, go to New Kotlin File or Class, and we're going to create a data class called Settings. Settings is our first data model, as I like to call it, or a plain old Kotlin object, and as we'll see in a moment, it will contain both the difficulty and the boundary, which is the size of the Sudoku puzzle. So a 4x4 Sudoku puzzle will have a boundary of 4, a 9x9 will have a boundary of 9. The data keyword, when put ahead of a class keyword, basically adds or generates a couple of helper methods, such as equals, hashcode, or copy. We'll definitely be making use of copy later on, maybe not in this class, but in some of them. And at a certain point, we will also make use of the generated hashcode function. Anyways, this is a really simple class. We're just going to add 2 properties to it. And that's it. Right-click on the domain package, go to New, Kotlin Class or File, and this time we're going to create a class called User Statistics, and that's going to be a data class. Now, the purpose of this class is to represent the user's shortest/best times for solving any particular difficulty or size of Sudoku puzzle. So we're basically just going to add a whole bunch of properties that are pretty much the same. Now, one thing you can do in IntelliJ IDEA or Android Studio is you can just click there and then hit Control D however many times you need, and that will copy to a new line. That's basically it for this class. Now you might be wondering, why are we using long here? We're actually storing the time it takes for the user to complete a particular game in milliseconds, so that's why we want the long integer value. Again, right-click on the domain package, go to New, Kotlin File or Class, and this is going to be a data class named Sudoku Node. Now, this is where things start to get a little more complicated and interesting with our data models. So what I'm doing here is I'm representing an individual node in a graph data structure. We're going to talk a lot more about graph data structures later on when we get to the part of the tutorial dedicated to it. But just to give you an idea, so we are actually going to be building a directed colored graph. And an important thing here to note is that in this particular case, this term color really just refers to a number. It's just a value we associate in some kind of node. And again, to give you a preview ahead, when I say graph data structure, a better name for it would be a network data structure, because that's essentially what it is. It's a collection of nodes and edges, which are essentially like lines between the nodes, relationships between the nodes. Anyways, this particular node structure in our data structure is going to have a color or a value, which is just an integer from 1 through 9 or 1 to 4, also including 0. 0 represents like an empty Sudoku tile, but that's more a concern of the front end. These nodes will also include an x and y coordinate, so the top left will be x0, y0, the bottom right will be x8, y8, and we're going to be using zero-based indexing. So instead of starting from x1 to x9, we just basically subtract that by 1. So that's it for that preamble. Let's get started writing the code. So we'll start with the x and y values. Next, we will add the color, which will be a variable because it can change throughout the course of execution. Then we will add a Boolean called read-only, and I'll explain what that is after we write it. Now, the purpose of the read-only Boolean here is quite simple. When we essentially generate and then unsolve a Sudoku puzzle, which is another way of saying we create a new Sudoku puzzle, then remove a certain number of clues to make the game actually playable and fun, some of those numbers on the Sudoku board or in the Sudoku graph data structure will be read-only. Those are like the given clues that the user is not supposed to be able to change themselves. As we'll see later on, this will also affect the user interface because we will draw the read-only Sudoku nodes or tiles differently than the ones which the user can edit. Now, we're not quite done yet. We need to override the hashcode function, which was provided by the data class keyword, as I discussed earlier. And then we also need to add a function to get a hashcode. Okay, so hashcode will have a default implementation, which is based on the values provided up here in the different properties. We're actually just going to do something different. So we're going to type get hash, like that. And this is actually a function that we are going to create. Also, we'll add in 2 parameters here for x and y. Okay, we're now going to add the getHash function, and it's going to be top level, which means it sits outside the brackets of our Sudoku node class. Okay, let's just implement this function, and then I'll explain what we're doing here. Okay, so let me start by explaining what exactly a hash code or hash value is. So it's essentially some kind of generated key or unique identifier based on some kind of algorithm. In this case, I have a very simple algorithm. All I do is multiply the x value by 100, and I leave the y value alone, and I basically just combine those 2 values together into an integer. Now, the reason why I multiply x by 100 is if I didn't do that in a 9x9 Sudoku puzzle, there would be certain edge cases where even though the x and y value are technically different, the resulting hash code would not be unique for several different nodes. Simply put, I'm multiplying by 100 to make the hash codes unique for every individual tile in the Sudoku puzzle. As for why we're using hashcode in general, I'll try and keep it fairly straightforward. Basically, we're going to be storing each node in the graph in a linked hash map. So the hash values will represent the key for that hash map. A hash map has key value pairs, in case you're not aware. We'll be seeing that in a moment. But this turns out to be really useful because our user interface as well will be representing things in that kind of x and y coordinate style. So just take my word for it. Hash codes are pretty handy in situations where you have a large number of elements and you don't necessarily want to have to maintain a reference for every individual element. Instead, we can just retrieve a reference by getting a hash code. Oh, and before we go, we need to add one more thing here. We're going to make this thing implement serializable. Now, essentially what this does is it allows us to read and write our Sudoku nodes and also the whole puzzle to a file. Since we're only going to be storing one puzzle at a time, I didn't really want to use something like a database. It kind of just made more sense to use the file system, and serializable makes it easier to do that essentially. Okay, we have one final data model to create in this particular package. Again, right-click, New, Kotlin Filer class. This one's going to be called Sudoku Puzzle, and again, it's going to be a data class. A good way to think of data models, as I like to call them, is that they are virtual representations of a real-world object, in this case a Sudoku puzzle. The way that I initially designed this class is by asking critical questions about what constitutes a Sudoku puzzle. Things like the boundary, so are there 4 tiles per row or column, or are there 9 tiles, for example? We have the difficulty, and most importantly, we have the graph data structure itself. There's also the elapsed time which the user has taken to solve a particular puzzle. So let's go ahead and add those properties in, and then I'll explain some of them, the ones that need to be explained afterwards. Also, before I forget, let's add in the serializable implementation here. Okay, so you're probably wondering what build new Sudoku is. So what we'll be doing is we're actually going to be calling a large series of top-level functions, which will form all of our different algorithms which are necessary to build and generate a new Sudoku puzzle based on a given size, which is what boundary represents, and a given difficulty. Also, if you're wondering about what's going on with the linked hash map, which is full of linked lists, that's kind of a way of representing an adjacency list. Again, I'm going to go into those details on graph data structures and different ways you can represent them, or at least how I represent them in this particular application later when we get to that particular package and topic. But for the time being, understand this represents our virtual Sudoku puzzle. The last thing we're going to do is just add in a small little method which just makes it a little more obvious and legible how to get a hold of the graph itself, at least in my opinion. And we're going to use single expression syntax, so I'm just going to type equals graph. Let's create a new interface called iGame repository. I like to use this naming convention of putting a capital I in front of the interfaces, and then as we'll see later on in the persistence package, I will add a suffix of impl, which stands for implementation, to naturally the classes which implement this interface. When designing a small to medium scale application, one thing you can do is you can actually conceptually think of the functions in your repository interfaces as use cases themselves. The things we're going to be writing here are going to be called like save game, update node, which is very similar if you were doing like a user stories into use cases type application design. So I just wanted to throw that in there. In a more complicated application where I needed to do more coordination of multiple different data sources and repositories, I probably would have like an interactor or a use case, as it's commonly talked about, between Martin Fowler or Robert Martin, Uncle Bob. But in this particular case, in simpler applications, generally speaking, the use case as a class itself is typically an unnecessary extra layer of abstraction. So with here, we're just going with our presenter or view model or whatever, talking directly to a repository, and that is a sufficient amount of abstraction for an application of this size. Now, how an interface works is that it's very similar to a class, except, as we'll see in a moment, we're not actually allowed to implement or give a body to the functions that we'll be writing. We just write what are commonly called either abstract functions or function stubs. Now, there's two important points here. Firstly, the suspend keyword is applied there because these functions will actually be called from coroutine scopes which exist in the logic class or the presenter that will be referencing this particular interface. So that's all we need to do to establish concurrency for now. Now, in case you're not familiar, what I'm using here is what's known as a function type. And so what we'll do is we will be actually passing in a reference to two functions which exist in the logic class, the presentation logic. We'll pass those functions in, and then in the repository implementations, the things which implement this particular interface, that is how they will call back with some kind of result, either a successful result or a failure. Now you might be wondering, why do we have unit and then it returns unit, which is what that arrow means. In this particular case, this is something we kind of have to do in order for the Kotlin compiler to understand exactly what we're telling it to do. So this would be kind of equivalent to passing in void, or like basically nothing, into this particular function and then returning nothing from that particular function. But what it will do is it will signal something like an onComplete, if you have any experience with RxJava, where basically we just want to resume the application successfully when this function is called, but this particular function does not actually need to return anything. Later on, we'll see some examples of when we actually need to return a value through our onSuccess function type. Again, you might be wondering what is the difference between saving a game and updating a game. Well, essentially in the update game function, we're going to be wholesale writing an entire Sudoku puzzle, which includes an elapsed time. Although there are some situations where all we really need to do is simply update the elapsed time of the game, such as when the user navigates away from the application. So what I'm doing here is I'm creating sort of specialized functions depending on what we want to achieve from the user's point of view. Now I'm going to demonstrate when we actually want to return a value from these particular function types. Okay, so for onSuccess, what we're effectively saying here is that this particular function must be called with some kind of Boolean value, obviously either true or false, when it's called in the implementation of this particular suspending function. Now, basically what we're doing here is when the user updates a single node or tile in a Sudoku puzzle, there's a possibility that that might be the final tile in the puzzle. And in that particular case, assuming the puzzle is correct and the user has inputted the final tile, that would signal that the game is complete. So it might be a little bit confusing here, but onSuccess does not necessarily mean that the game itself has been completed. So that's why I'm differentiating there. Okay, now in this particular case, what we're doing is when the user returns to an active game, we obviously want to get a current game. And there is actually an edge case where the user completes a game, navigates away from the application, and then restarts the application. And so that's why we're still passing in that isComplete flag. Here we're going to return, obviously, a settings object. Let's create another interface. And it's going to be called iGame Data Storage, and that's obviously an interface. Now, before we write the interface itself, we're going to do something a little bit different. We are going to create a result wrapper, or, well, let's just say it's inspired by an either monad from functional programmers, but no one really cares what functional programmers think or talk about anyways. Sealed classes are truly one of my favorite simple features of the Kotlin programming language. It allows us to create a restricted set of types and those types can contain particular values. And basically what this will do, and as we'll see in a moment, is it allows us to return an object from a particular function of iGame data storage. And this particular object is capable of representing multiple different states. So like I showed you before in iGame repository, here we're representing an error state and a success state as two separate function references. In this example, we're going to be representing both of those states through a single object. Now, one final point before we move on. If you have, for example, some kind of situation where you want to represent just a success case, so equivalent to just returning a unit in onSuccess, what you can do is you can actually just use an object. So you could say like object on complete, etc. But we don't actually do that in this application, so you don't need to add that in. Now let's finish off the interface. Create another interface called iSettingsStorage. Now we're also going to use result wrappers here, so I'm actually going to just copy and paste this over. And we're just going to rename a few things. Okay, and now we can rate the interface. One more interface to go for this package. This one is going to be called iStatistics, if I can spell it, repository. And obviously it's going to be an interface. Now, one final point, again, isRecord is going to actually affect something in the user interface based on whether or not a statistic that gets updated is a record, i.e. the shortest possible time of completion for a particular boundary or size of Sudoku puzzle, and a particular difficulty.